basically if we are interested to check the relationship between the variables. Okay, that means if we want to know the correlation between the variables. So for that we have three types of the plot. Either you can use scatter plot, either you can use bubble plot, or either you can use correlogram, which is also known as visualization of the correlation matrix. Okay, the scatter plot we can use whenever we have the two quantitative variable and we want to know the relationship, whether they have the positive relationship or whether they have the negative relationship between each other. Whenever you have three variables, okay, then you can use the bubble plot. Okay, as you can see in a scatter plot, we get examine anxiety variable and exam performance, and we can see that as the exam anxiety start increasing, so exam performance start decreasing. So they have the negative relationship or negative correlation with each other. So against the same data set, we have the exam anxiety on x-axis, on y-axis we have the exam performance, and the third variable I am considering is the revision time. Okay, so we know that from the scatter plot that as the exam anxiety start increasing, the exam performance is going to be decreased, which means they have the negative relationship. But we can also see that if the revision time is increases, so the exam performance is increases, as well as the anxiety level is also be decreased. Okay, so with the help of the more revision time, we can increase the performance as well as we can decrease our exam anxiety. Yes, colochrome is also known as the heat plot as well. Okay, so you can also use hologram as a heat map as well. But heat map can also be used for other purposes as well. Okay, but whenever we have more than three or even three variables, we can use hologram, or you can say the correlation matrix. So as you can see that for that I am using basically the same data set of cars, empty cars. On x-axis we have the different types of the variables, okay, and as well as on the y-axis we have the variables, okay, like mileage per gallon, gear variable we have horsepower, weight of the car, okay, the same we have. And as you can see that these different numbers are representing the correlation between those variables. Okay, the different colors are having different meaning. What are that one? Let me draw this one and then we will discuss what's the meaning of this one. Okay, first of all, what I am going to do is, in order to draw the scatter plot, I am using a data set which is the exam anxiety. So this data set I am using, which is basically in the format of dot and dat. Okay, so in this particular data set, we have a variable code, we have the revision time, we have exam, we have anxiety, we have gender. So first of all, I am interested in order to know if the exam anxiety having any relationship with the exam performance or not. Okay, so for that, first of all, I am reading this data set. So right now I'm using a function read.delim, and then I'm mentioning the name of the data. Okay, if the data set is in a same you can say folder in which we have the R Studio project, so then if you there is no need to mention the exact path of your data. So you just need to write down the name of the data, and then R is going to be read that data set. So if I run this command, now we can view this data set. Okay, as you can see this one, we have code, we have revision time in hours, we have exam performance, we have anxiety level in terms of percentage, we have gender variable. And with the help of this scatter plot, we can visualize it. So how we can do that? I am saying draw a ggplot. So this is basically the structure of ggplot, which is the name of the variable in which we have data set. Okay, then on x-axis, on y-axis, then I am saying because this structure is added into a variable called scatter, then I'm saying scatter dot. I want to draw what kind of plot? That is GUM point. So point means scatter plot, and then I'm mentioning x-axis label and y-axis label. So if I run this command, okay, so now you can visualize this scatter plot, and we can easily see that exam anxiety and exam performance having a negative relationship. Okay, so if I want to add the regression line in this scatter plot, how can I do that? GUM point plus, by using the function GUM smooth, and method is LM, which is a linear method. Okay, and then I'm mentioning the color of that line, as well as I'm mentioning the standard error is equal to false. Okay, what does this mean? So if I run this command, now you can see that this is going to be showing me the regression line. Okay, and we can see that the regression line having the negative slope. Okay, so negative slope means they have the negative relationship between each other. Okay, so the standard error is going to be false, mean this ggplot is not showing us the confidence interval. So if I remove this one, mean if it is going to be true, which is by default it is. So right now I am saying GUM, the empty and then smooth. Now I am removing this thing. So the rest of the thing is same. Now, as you can see that this basically dark gray color is indicating the confidence interval. Okay, so by default it is 95% confident. The regression line is going to be like within this range. Okay, the next thing is if I want to see this regression line, okay, with the with different colors. So what I am doing is, in addition to this one, I'm mentioning alpha is equal to zero point 0.1 and fill red, so that this alpha is basically indicating the you can say darkness of this color. So if I am increasing this number point up to zero point 0.5, so you will see that this background red color is going to be much darker. Okay, so as you can see this one, so then fill is basically the red line of that regression line. Okay, so let me again switch to zero point 0.1. Okay, so similarly, now if I want to can you hear me?
Yes,
Okay,
we can hear.
okay. So now, if I want to add the confidence interval with respect to the gender wise, so basically, I want to know is the exam anxiety and exam performance having any relationship with respect to the gender? Okay, mean male and female perspective. So if I run this command, now we can see the different lines of for the male and as well as the female. So no matter whether it's a male, whether it's a female, as an exam anxiety start increasing, the exam performance is going to be decreased. So this is we can use the scatter plot. Even we can add the regression line and the confidence interval of the regression line in order to check the relationship between the two quantitative variables. Now, if we are interested with the help of three variables, so that means we can use the bubble plot. So again, for that, again, I'm using a data set called empty cars, and I'm drawing the bubble plot with respect to weight is a quantitative variable, mileage per gallon, and the size of the bubble is with the help of horsepower. Okay, so if I run this plot, so now you can see that smaller the horsepower, the smaller the bubble size is. So larger the horsepower, so larger the bubble size is. Okay. So as we can see that the higher weight cars having the higher horsepower and having the lower mileage per gallon. Okay. Now, if I want to improve this bubble plot, mean by adding some colors. So with the help of alpha, that is basically using for darkness of the color. So we are filling with red, okay, and then adding the shape sizes, okay. So if I run this one, so now you can see that we have labels x-axis, y-axis, as well as added the title, as well as changed the color of the you can say bubble plots, okay, as well as the size. So the size of this bubble plot is going to be increased with the help of this range function from 1 to 14. So if you are going to mention from 1 to 5 or 1 to 6, the size of bubble plot is going to be reduced. Okay. So that's why for that we are using the function called scale underscore size underscore continuous. Okay, so I'm using the bubble plot for the dataset exam anxiety, which I am showing you earlier. So for that, on x-axis, I'm mentioning the exam anxiety, y-axis exam performance, the size of bubbles are going to be revision time, and then I am saying fill is equal to gender, so which means different bubbles are going to be showing the different gender. Okay. So as we can see that on x-axis we have the exam anxiety, on y-axis we have exam performance. The different size of the bubbles are indicating the revision hours, the revision times, okay, and different colors are indicating with the different genders, okay. So the interpretation is the same. As you can see that higher the revision time is going to be reduce the exam anxiety and improve the exam performance. Whereas if we are spending lower time on the revision, so the exam anxiety as it is going to be start increasing, our exam performance is going to be decrease. Okay, in most of the cases. Okay, now I am moving towards the third type of the plot in order to represent the correlations. So that is basically visualizing the correlation matrix. So in order to draw the correlation matrix, we need another package, which is basically, you can say the extension of the ggplot2 package, which is ggcor double r plot, okay, which is basically a graph of grammar correlation plot. So first of all, we need to install it. So once we install it, we have to call this library, and I'm using again the empty cast dataset in order to draw the correlation matrix, or you can say cologram. So now what I am doing is I am calculating the correlation matrix. So how can I calculate the correlation matrix between all the variables in the empty cast? So I'm you call the function COR, that is basically the correlation function, and I am saying round this correlation up to 1 decimal point. So and then I am storing that correlation matrix in a variable CORR. So if I run this command, we can see that this is a correlation matrix between all the variables. Uh, I hope you know that the correlation matrix is always a symmetrical matrix. So what does that mean is, as you can see, the diagonal values is always going to be 1. Okay. So the upper matrix, the upper side of the matrix is going to be exactly equal to the lower side of the correlation matrix. So that means either you can show the upper side of the correlation, either you can show the lower side of the correlation. Both are indicating the same type of the result. Okay, so this is known as full correlation matrix. Now, in order to check whether this MPG and horsepower correlation, which is saying that the correlation between mileage per gallon and horsepower having the negative relationship, which means 80% of the time as the horsepower start increasing, the mileage per gallon is going to be decreased. Now I want to see whether this relationship is significant or not. So for that we can calculate the p-values against this correlation matrix. How we can do that? That is cor underscore p-mat and then the name of the variable in which we have the data set. So basically we want to find out the correlation p-values matrix. So if I run this one, and then instead of writing head dot, I am mentioning p dot mat, in which we have the entire p values matrix. Okay, so as you can see that so this is the p value. Okay, this is the p value. So what's the interpretation? The interpretation of this p value is our null hypothesis is h naught rho is equal to 0, whereas alternative is rho is not equal to 0. So that means no correlation between two variables. okay, and where this means there is a correlation between those two variables, okay. And the decision making criteria is if the p-value is going to be greater than or equal to your pre-decided alpha, which is approximately most of the time we are considering 5%. If this condition is true, we are going to say except h naught. Okay, so that means there is no correlation between the variables. If the p-value is going to be less than alpha, so then we will say reject h naught. Okay, so reject h naught means there is a correlation between the variable. So as you can see that uh, so the p-value is less than 5%. So that means we can say that MPG and CYL between these two variables having the significant correlation. And what kind of correlation? With the help of this correlation value, we can tell that whether it's a positive or negative. So we can see that this is a negative correlation. Similarly, I can see that between MPG and horsepower, this is over here the p-value is also less than 5%. So this is there means there is a significant correlation between mileage per gallon and horsepower, and they have the negative relationship. Okay, so I hope it's clear now how we can calculate the correlation, how we can calculate the p-values. So now we are going to use this correlation matrix results as well as the p-values matrix result in order to draw the cologram. Okay, so for that I am calling a function from this package ggplot, and I am entering the variable in which we have a correlation matrix. Okay, so if I run this one, so I can see this correlation matrix on x-axis, on y-axis we have the same set of variables. Okay, as you can see that this diagonal is basically indicating the same, which is basically 1 1 1, and you can see that so the negative correlations are going to be shown with the blue color, okay, whereas the positive correlation it is showing in the red color. So lighter the red color is indicating the lighter the correlation between the variable. Darker the red color is indicating, and the darker the blue color is indicating the high correlation. Okay, so instead, if you want to see instead of squares, you want to see the circles. Okay, so then you need to add method is equal to circle. So if I run this command, now you can see instead of squares, this is the circle. Now, what I'm doing is I'm applying the hierarchical clustering. What this hierarchical clustering mean? As it is going to apply the similar type of correlation, which means if the variables having the higher positive correlation, it is going to be clustered at one side. If they have the negative correlation, it is going to be clustered on the other side. So that means what is going to be happen, it is going to be rearrange these variables in a way, however we would be able to see the high correlation variables on one side and other lower is going to be on other side. Okay, so if I run this one, now you can see that they have rearranged it. Okay, so over here we can see the negative correlations cluster. Over here we can see the positive correlation cluster. Okay, similarly over here we have the positive correlation. So this graph is rearranged to this one by applying hierarchical cluster approach. Okay, now if I want to add the correlation coefficients in this particular graph, what I can do, I can add label is equal to true. The rest of the thing is going to be same. So if I run this one, so now you can see that the correlation values are going to be added in that one. Now, if I want to add the p-values, so it is not going to show us the p-value, but it will show us the cross if that the correlation between those variables are not significant. Okay, if I run this command, now you can see that some of are crossed. So that means between those two variables, there is not a significant correlation between the variables. But if it is not crossed, So that means those variables having the significant relationship between each other. Okay. So as I mentioned earlier, that the correlation matrix is always a symmetrical form. So that means either you can represent the upper triangle or either you can represent the lower triangle in order to show the correlation between all the variables. So that's why at the last I am showing type is equal to lower, or either you can mention type is equal to upper. So in order to add this one, if I run this one, now you can see that it is showing me the lower triangle and it is showing me the correlation. So I haven't added the p-value over here. So if you want to add that one, so you can just simply copy it and paste over here. It will show us apply the cross if there is no significant relationship, but if there is a relationship, it will showing us without crossing. Okay. As I told you earlier, so different color is basically indicating the different type of the correlations. Right now, the red color is indicating the negative correlation, whereas the green color is indicating the positive correlation. So the lighter the green, lighter the red color is indicating that means there is low or there is no correlation between those variables. So I hope it's clear that if you want to show the relationship between the two quantitative variables, so for that we can use either scatter plot or a bubble plot or a correlogram.